Hi, everyone. Welcome to another session of this year's GSC UK virtual conference. Today with us, we've got Roland Koo and James Tang. They're both from IBM in Canada. This is session 9J, and we'll be covering how to modernize business critical applications with latest compilation technology and take full advantage of the IBM Z16. Now, any questions that you may have, please raise them on the chat box, and both Roland Koo and James Tang will be answering them as they go. And at the end of the presentation, I will allow you to unmute yourselves and ask any questions directly to the presenters. So with no further ado, Roland, the floor is yours.
Thank you very much, Rui. Welcome all to this session, and thank you very much for joining. Today, we're going to be talking about how the compiler and language portfolio can actually help you modernize your business critical applications on the IBM Z16, because that's our latest platform. And I'm Roland Koo. I lead the product management team for compilers and languages. And today I'm joined with James Tang, who is the product manager for Java and Go. And we're going to be doing this presentation together. So I'm going to be covering the first part, and then James is going to be covering his favorite topics of Go and Java. So let's move to the next chart. So here's the agenda for today. We briefly go over, the benefits of adopting a hybrid cloud strategy for application modernization. Why is it going to be a good approach for your digital transformation? Handling a digital transformation so that you can be more competitive in the market. And we're talking about, what we mean by modernizing applications on ZOS. And then we'll go through the compilers and language portfolio and tell you how you can actually make use of them. And then we'll summarize at the end. So as we know that many companies are, really doing digitally transforming their business, right? They want to be more competitive in the marketplace. They want to be more friendly to their users. And this is really driving a lot of the demand on existing data and applications. Because you would really want timely access to critical applications and data so they can actually get insights that you can provide to improving the business critical applications that you currently have, right? For example, if you have a integrated view of client access data through multiple applications in a banking environment, you can actually extend your service to providing mobile customers access to their banking information, and you basically can improve your loyalty program, or you talk about a little bit credit card disputes or credit card related things. You can all put them together and do it pretty efficiently. So let's move to the next chart. So we talk a little bit about hybrid cloud. A lot of customers are really starting on their cloud journey. But a lot of them are really pretty siloed at this point. So what you get is really a heterogeneous environment that is really not, working with each other. Basically, you have different departments doing different things, and your development teams is also siloed, and there's a lot of duplications going on, a lot of inefficiency going on. But with a hybrid cloud approach, what you can do is you actually transform all that, right? All that you can do today, in a heterogeneous environment into a common platform. And you have a single integrated fabric, and to IBM, that fabric is the OpenShift plane that you can actually manage all your applications together and really make the, and make them sort of like a set of common processors, which, basically you can look at it in a more integrated point of view. And that's really what we're talking about when we talk about a hybrid cloud platform within IBM. Let's move to the next chart. So we have challenges, right? Because we do have, applications that are really running well, like your COBOL PL1 applications, that changing them or adding, more capabilities to these applications obviously will come with business risk, and you'll be faced with, skills shortages and, a skills challenge as well. And also a lot of these are monolithic applications, and, applying software, agile software development strategy to them could be a little bit more challenging as well. So we wanted to address all this, hopefully through the what we can do in the compiler portfolio and the language portfolio today. So when we talk about modernizing applications on ZOS for hybrid cloud, we're looking at really three things, right? One is optimize the applications so that you can get the biggest ROI that you can ever get when you invest on the IBM Z platform. Because the IBM Z always comes out with new hardware. When we come out with new hardware, we will come up with a new version of the operating system, middleware, and also compilation technology. So staying current with this, with this set of technology is the best way to go to be able to fully utilize the capabilities of the platform. Then, because a lot of the applications you're running today are working very well, right? So really, the other thing that we'll encourage you to do is to extend. Rewriting doesn't give you a lot of benefit. It will only increase a lot of risk, and it will increase the cost for you as well. But if you keep extending, your applications, we're basically providing you better ways to extend your applications. Like, for example, if you are extending your application using the language that your application is written in, like COBOL, PL1, C++, or Java, we always will ship new features to help you, do that, right? And also for the new applications, you really don't have to, be bound to be extending your COBOL applications with COBOL. You can actually use other languages in the portfolio, like Node, Python, or Go, to write your new applications, and you can actually we'll make sure that it will interoperate with the existing languages that your application is written in. And the other thing is that, many customers already have been using Node, Python, or Go, and Java applications on other platforms, but they have to access data or core applications on ZOS. So for those applications where it makes sense, right, you can actually, it's better to maybe co-locate to optimize the response time and throughput. So those are the three things that we talk about when we talk about modernization, for ZOS applications. So our compiler strategy or language strategy is also trying to, move in that direction, right? So our bread and butter core technology is optimization. We work very closely with the hardware team, right, to bring out new instructions or new features in the hardware to improve the performance of workload on ZOS. And this workload would increase, will include COBOL, PL1, C++, Java, everything that we have in the traditional sense, right? And we also are continually to deliver new language features to help you modernize applications. Like, for example, we added native XML and Java support and UTF-8 support in COBOL PL1, right? We actually added 64-bit support to those languages, and we also make them interoperate with 31-bit applications as well. So you don't have to, convert all your applications to 64-bit, which would take a lot of effort to be able to take advantage, to be able to go over the 2 gigabytes addressing space that you need for your application. And we also put in the, in COBOL, Java interoperability. We make it simpler so that you can use it, a lot easier. And also the new COBOL language features that we decided to do it, right? And then the new thing that we added into this strategy is to embrace open source technologies and ecosystems. We have introduced Node.js, Python, Go, and you can argue that Java could be an open source language as well. We are actually bringing these these open source framework to the portfolio just to make sure that, we are giving you choices or enabling you with options that you can use to modernize your applications. And also, obviously, we will continue to respond to our customer requests. Now, by bringing the new open source technology enabling on the system also drags along the ecosystem of those technology as well. So that will give you a lot more options moving forward. So let's move to the next one. So here's a portfolio that we're talking about here, right? We have our traditional COBOL that just refused to retire and still, still performing very strongly. We have automatic binary optimizer, which is the binary optimization technology for COBOL applications. PL1, same case. We also are, updating our assembler to support the platform as well. And we have C and C++. And then on the other side, these are the newer kid on the block, like assembler runtime is really Java, which James will be taking you through later on in the presentation. And then we have Node, Python, and Go as well. So let's talk about the COBOL, the traditional language. So when earlier I said that, we work very closely with the hardware development team to put in new features. And this is an example of what I was talking about, right? If you look at the past 5 generations of the current 5 generations of the IBM hardware, starting from the EC12, you can see that we actually have put in a lot of facility to improve the performance of COBOL applications. Right? That's why when we come out with the new COBOL version 5, version 6, we encourage a lot of people to move on, to adapt to, to upgrade or migrate to the latest version. It is because of these new features that we put in, because these are hardware features. The only way that you can take advantage of it is by exploitation. And the only way to exploit it is to have the right instructions in your executables. So that's why it's very important to make sure that you stay current with with the technology, as you upgrade your hardware. Let's move to the next chart. So I wanted to go over a little bit new direction that we're going with COBOL. For the past 5-6 years, because of the push to move people to encourage customers to migrate to COBOL version 6, we basically focus on improving the migration side of the house, right? But now that COBOL version 4 is out of service, we want to look forward, and we really wanted to drive the language side of the house right now, right? So something that is staple that, with platform exploitation, the stuff that I just talked about in the previous chart, is baked into the hardware roadmap. So every generation, we're going to be coming up with new features, and we're going to be having the corresponding compilers technology to exploit those features. But for this particular release, COBOL 6.4, which is the latest one, besides exploiting Z16, we also simplify the COBOL Java interoperability, because we know that a lot of customers choose Java to extend the capabilities of current business applications written in COBOL. So the improvement that we put here is that we have removed the need to write OO COBOL or object-oriented COBOL syntax, right? We get rid of that. And in the past, you also have to write a lot of manually, JNI calls and stuff like that. So the way that we're simplifying it is that get rid of OO COBOL syntax. We purely use JNI, but those JNIs, a lot of them are going to be provided in the library, so you basically don't have to do a lot of writing of those things. So we'll make it easier for you to use this interoperability, make it easy for you to extend your COBOL applications using Java. So 31-bit 64 interoperability, we know that a lot of the COBOL program, or maybe 90%, 95% of COBOL programs today are AMO31 programs, right? But the 2 gigabytes addressing space as data growing, so rapidly, you're going to be running out of that addressing space very quickly, right? So then we add in the AMO 64-bit support, which gets you beyond that 2 gigs addressing space. But also we now give you the convenience of making making your 31-bit program interoperate with 64-bit program and vice versa. So you don't have to convert the entire COBOL applications to AMOS 64 just because you have certain programs that you need to go beyond that 2 gigs addressing space. And we're also putting in new features, new language features to make COBOL more friendly to new developers. The first feature that we'll put in is user-defined functions, and we have a lot more to come now that we are over that migration phase. And we also have better integration with automatic binary optimizer, which I will explain later on in later on in the presentation. Let's move to the next chart. So you say, okay, what's new in IBM 16? For my COBOL applications. So we as every new generation of hardware, we come up with a new something called arch level, architecture level. So for Z16 is arch 14. And when you turn this thing on, then you will be able to optimize applications that have exponentiation operations, unpack the zone decimal data. You can have mixed decimal and floating point data items. Those will be optimized. And numeric data items like numeric edited data items. Those three are very commonly used in a lot of COBOL programs. And when you look at the Z14, when we started with the putting in the vector packed decimal facility, we eliminated all the overheads for packed decimal arithmetic and zone decimal arithmetic, and then we keep putting on these kind of improvements, and this is the latest set of improvements that we get. And if you look at the performance on the right side, we look at, if you're still on COBOL 4.2, you're leaving a lot on the table, right? So you're leaving 57% of performance on the table, like 5.2 you have 30, and so on. But if you're getting to COBOL 6.3, because we don't have a lot of these, granted that these numbers are generated by our internal benchmarks. We don't have a lot of benchmarks that touches whatever I just said. So you have 2%. So, but these things are just a guideline for your information. Depending on how much code you have, that would benefit. With the optimization, you probably get better or worse. So let's move on to the next chart. So here's a history of what we do. Like, right, if you keep up with the hardware upgrades and you keep up with the COBOL upgrade, if you look at from EC12 to now, we're looking at around 3.5 times performance improvements. Let's move on to the next chart. So I want to talk a little bit about automatic binary optimizer, right? So first of all, what it is. The ABO automatic binary optimizer is a unique optimization technology that we provide for COBOL applications, and it targets ZEC12, hardware architecture all the way up to Z16. And what does it do, right? If you look at the optimization process, it shares the same optimization technology as COBOL, but when you optimize with COBOL, you optimize from the source. But when you optimize from ABO, you optimize the binaries directly. So it maintains very strict compatibility with the original binary. So all this migration headaches that you have with invalid data, ABO doesn't care. It will just optimize the code for you. So that's why it will give you, a good CPU reduction, improve the performance, which also reduces the processing time for your critical applications. And if you look at code that you haven't compiled for a long time, this would be a good way to get performance. Because it doesn't have any source risk to it. It directly optimizes the executable or the binary. Then you don't really run into a lot of any of this migration challenges that you have moving to version 6. So let's move to the next chart. So with ABO, it seems to be quite straightforward that, hey, you just need to optimize the binary, and then the binary would take care of the platform, so you can reduce processing time, you can reduce CPU usage, and you can reduce costs, right? So that was the original assumption, but unfortunately, there's some challenges, when we try to to implement or to deploy this product in customers' site. The reason is because usually you have a lot of modules, right? If you have 200,000 modules, you want to know where you start, right? Because a big bang optimization, sometimes is not the best strategy to go, right? We recommend an iterative approach, right? So you find the biggest CPU consumer, you optimize that, and you keep going, right? So then that will give you a better value for you, right? So ABO, when we come out, so that is the biggest challenge. And ABO 2.2 is trying to address a lot of those challenges because we put in something called ABO Assistant. And ABO Assistant is something that we try to automate the process for trying to find the biggest CPU consumer for this, for Cobalt, and then we will, generate reports, and so that you can actually more methodical to process to optimize your applications. And also when you talk about a Cobalt and CICS applications, it's a mixed applications, and ABO is only an Cobalt optimizer. So the challenge is even more challenging because that you cannot optimize CICS. And if you look at the load module, the CICS portion of it, you cannot touch, right? You can only touch the Cobalt portion of it, right? So basically making it more challenging, even more challenging to find out which is the big which module actually have value for us to optimize. So bringing tools like this will be able to help you cut through a lot of manual processes so that you can get to the modules that you wanted to to optimize a lot easier. And ABO 2.2 also fully supports the architecture. So performance-wise, it's pretty similar to what the Cobalt compiler can give you. Also, one of the things that we did here is to extend the eligibility for optimization from VS Cobalt 1.3 to Cobalt 6.4. So you can actually extend that, that roadmap so that you can, by extending the eligibility, that means that you can keep optimizing code that you do not compile for a long time with ABO. So let's move on to the next chart. So as I said, performance-wise, it's pretty similar. So 56% if you're still on, advantage if you're still on Cobalt 4.2, 20% if you're at Cobalt 5.2, and then release to release, if you do Cobalt 2.1 versus Cobalt 2.2, you still get a 5% improvement. So that's pretty good. But the previous version of ABO stops at version 4.2. So the eligibility is only from VS Cobalt 2 1.3 all the way to 4.2, and with ABO 2.2 you can extend it to 6.4. Let's move to the next chart. So I talked about the ABO assistant. Basically, it is a suite of products that help you eliminate the manual and time-consuming tasks for identifying top CPU consuming. It actually works on based on SMF record and low-level profiling data. We actually generate pretty concrete performance evaluation for you there. So it is really good for doing a proof of concept to deployment. Let's move on to the next chart. So I want to leave you with some customer stories here. Unipolsai is a Italian insurance company, and they were moving to version 6.2. Version 6 compiler 6.1, I guess. And they, instead of recompiling everything, they actually use ABO as well. So collectively, they get a CPU reduction of about 10% on average. And this is really on the, this is a mixed application. This is a Cobalt, mostly Cobalt and CICS applications as well. So they get very good results and very good value. And they, and also reduce a lot of time for them to, for upgrading to the Cobalt 6 compiler. Let's move on to the next one. So Taiyo Life Insurance is an insurance company in Japan, and they use Cobalt to do actuarial calculations. So they are upgrading to Cobalt 6, but they find out that they really don't have to go through that complexity if they use ABO, and got them very good results on the Z14. So this is a really interesting case study on very compute intensive COBOL application. So a large bank in Asia, they are, they have a lot of challenges with their COBOL code. They have a lot of COBOL code, and they actually used ABO as well. And they were actually get a big reduction in in CPU usage, and that really met their purpose. This is really a series of banking applications that they applied ABO to. So I want to move on to PL1. PL1 is still alive and very well, because we actually are investing, still investing in PL1. So if you are using PL1 applications, we're still we're still enhancing the product, and we're still doing the same thing as we do with COBOL in this compiler. So the latest release of PL1 is 6.1, and we actually replaced the compiler backend. If you look at the compiler, you basically see two big boxes. One is the front end, which deals with syntax and semantics, and the back end that deals with with code gen optimization. So we actually comment up the back end for PL1 with the strategic COBOL backend. So basically, we can make it upgrade to the latest technology base and more strategic technology base, so that we can better support the product moving forward. So it also supports, fully supports the Z16 architecture, and also allows interoperability between 31 and 64-bit applications. So in terms of performance, by moving to the new infrastructure, we save about 20% CPU usage in the compile side, and 18% on the application side of improvements in performance. So let's move to the next chart. So here are some links and some videos that I'll leave you with. I'm not going to go through it, but I encourage you to go through it so that you can see a little bit, watch a little bit more about what we're doing here for COBOL, for ABO, as well as PL1. So I want to move on to C and C++ for ZOS. C and C++ is really a feature. Basically, we have to read this chart backwards, right? So we have to write and then go into lower left and then go up. So C++ is an optional feature of ZOS. And it supports a Metal C, and you can actually modernize assembly applications and system programming with Metal C, which some things that you normally do in assembler. And we come up with some high-speed math libraries as well. And then we, and then we have two web deliverables. One is the XLC and C++ version 2.4.1. Because we're transitioning to the LLVM open source framework. The old compiler that's in the operating system is purely an IBM technology, but as we know that it's very hard to keep up with the language standards and all that, so we decided to move to the to base our product and use the LLVM Clang technology to as a framework for our C++, so that we can, concentrate on doing the optimization part to bring you the best value on the platform. So C and C++ version 2.4.1 is an interim hybrid thing, because that's sort of like a transition phase where we started using the Clang front end, but we still attach it to the IBM backend, right? And it only supports 64 bits and USS and runs on 2.4 and 2.5. But the value of this is to bring you more up-to-date C++ language features. And recently with C16, we shipped Open XLC and C++. This is really the full transition to the Clang LLVM technology. And it has full exploitation of the Z16 hardware and more up-to-date language support. And also but it still is running on 64-bit and USS only. We have plans to move it to MVS to put in 31-bit support, and then also Metal C support as well over time. So let's move to the next chart. Just want to leave you with this, like we have so many flavors, just want to make sure that everybody's not confused. We have the one that is in the operating system, it stays there. We have, C and C++ 241, which we only use the LVM technology for the front end. This one is really, if you're using this one, then we recommend that you go to the OpenXL C and C++, because that is the full LVM backend technology. Your front end code is pretty much the same. So that's probably, that's what we're recommending. And because the open languages also needed a free C and C++ compiler that's, no charge, we're making one available for, for use of this, for this language. So if you have to pull down a node.js npm and you wanted to install it and it requires a compile process, you can actually use this compiler. Same go for Go or with CGO, with Python. If you use ZOAU in Java, you can still use it because you're not developing applications with C and C++. So this is something that we delivered recently in support of the new languages. Let's move on to the next one. So here's some of the things, and I'm going to be transitioning, to hand it over to James so that he can talk about Java and Go.
Okay, thank you, Roland. My name is James Tang, and I'm the product manager for Java and Go on COS. Now, I will take you through Java first, and then I'll talk about Go. Just on this title slide here, you'll notice there are two names. There has been a rebranding update for Java to align with the rest of the distributed platforms on C systems. So we use now the Semru name. Starting version 11, the product is now called IBM Semru Runtime Certified Edition for COS. And before version 11, it's still called IBM SDK for COS, Java Technology Edition. On next slide, we have just another, you might wonder why the Semru name. It originates from the tallest mountain in the island of Java in Indonesia. And IBM Semru runtimes are built on OpenJDK for Java class libraries, on Eclipse OpenJ9 for the JVM. So both contain specific platform exploitations and performance improvements that our customers and partners need. The SDK includes the latest Java 11 language features and allows you to stay current with the Java community. Java code and runtime code are SIP eligible, which make Java workloads much more cost effective to run on COS. It also has a no charge license, and support of it is through entitlement of the operating system. Now notice that there are two editions for Semru runtimes. The open edition contains an open source license, and it's not technology compatibility kit certified. Now the certified edition, the one that exists on ZOS, and also on other platforms, you can choose on other platforms, but the only version available on COS is the certified one, which has an IBM license our customers require and is TCK certified, meaning that it is compliant to all the Java specifications as a programming language. The compilers team, and Roland mentioned this earlier, that we partner closely with the hardware team and operating system teams to optimize performance of all our compilers where possible running on the platform, and Java is no exception here. We have recently, on the launch of on C16, we have proven that our benchmark, Java EE, Java Jakarta EE applications on COS achieve an average throughput improvement of 19% better using the latest release compared to a release that was in C15. So we continue to make performance improvements in partnership with the hardware and firmware and other teams at IBM to produce the best performance. Now, IBM C16 exploitations include some of these ones that are listed here: vector packed decimal in the data access library, and also big decimal integer and long to string accelerations. Some low level hardware instructions are accelerated for Java workloads. And you also have cryptography, TLS 1.3, and CRC32 vector acceleration, it was mentioned earlier about the 31-bit native interoperability with 64-bit applications for Java on COS. So that's supported in the latest versions. Just server support to offload JIT compilation. So if you have you have a set of JITed classes in one instance. Those are shared among the Java instance clusters, and this benefits hugely for clusters of hundreds of JVMs, which a lot of customers do have, and general startup throughput and garbage collection improvements as well. And continuing the theme of decades of performance improvement, this is just to highlight the work that we have been doing for decades. And this is a typical day trader benchmark that we run on traditional Western application server that to release comparison, that we have seen increasing performance of each release of Java and was on each new level of hardware, now to the tune of 21 times aggregate performance improvements since WAS 6.1 running on Java 5 on Z9 to WAS 9 running Java 8 on Z16. Let's keep going. There's a list. Here's a list of popular use cases being used by existing clients using Java, and the number of JVM instances as the blue color coded on the right-hand side, and how many of those instances they have for each type of workload. And they range from key middleware usage, right? Like the popular Western application server, Liberty, CICS, KICS, IMS, and DB2 workloads, and other types of Java applications in Batch or Tomcat or Spring. This is from a recent COS client survey here. We know that 61% of the survey respondents are running Java Batch, and 43% run Liberty, 36% in KICS, and 36% in DB2. So those are the more popular ones I want to highlight to you. And on the next slide, there's another prime example that we partner with Atrivia to create a customer story on. In this Atrivia example, if you click on that full link and title Efficient Low Risk Modernization of Core Banking Applications, Atrivia is able to leverage Java alongside COBOL to preserve the best of both IBM C systems and distributed worlds. Atrivia is an IT service provider providing banking as a service to more than 800 banks with a network of more than 30,000 ATMs. They chose an incremental application modernization approach, not one of those high risk, high cost lift and shift type. They optimize the core and gradually extend applications with Java using APIs while co-locating with Java, with COBOL apps and data at the center of C systems to maximize performance. Atrivia has now Java-enabled 85% of core banking transactions, achieving around 400 million Java transactions per day, with peak throughput reaching 12,000 transactions per second. And those are no small numbers here. And direct quote by our customer, we see Java on IBM systems as a key technology in driving competitive advantage for our clients. Next slide is a set of resources for Java or SEMRU runtime, product page, blogs, whatnot, and a set of popular use cases like CICS, IMS, interoperability with COBOL and JSOS as the Java batch. Okay, next slide on open enterprise languages. I'll explain what that is and then cover Go, and then I'll pass to Roland to cover Python and Node afterwards. So now clients can use the best fit languages, right? That we provide what we call open enterprise languages that you see as Python, Go, and Node to develop new applications driven by the need to transform business and develop them quickly. Each language has their best strengths, right? Python is best suited for IT and DevOps automation, has use cases, a lot of use cases in AI and machine learning models. Go is best suited for building large-scale complex software and has use cases in cloud infrastructure like Kubernetes, Docker, or open container initiatives. Node.js is best suited for data-intensive applications and IO-bound applications because they're best known for non-blocking IO, right? So it will really helps with highly scalable network type of applications. Open enterprise programming languages give architects and developers more solution choices and tap into a broader developer skill base for business resilience and agility. And I would like to emphasize that point. There's a lot of universities and colleges out there, they already teach these languages, right? And it's really hard to find the traditional type of language. They don't teach that right out of school. So you can find a lot of developers and talent in these for developing new applications and extending your existing applications. So and to that point, to innovate even faster, there are a large number of ready to go right? Good to go packages to use instantly for your applications. These are, very powerful standard library of packages, built-in features to support your application development. There are tens of millions of developers writing code using these open languages, right? There's an open source community that support each one of these, like Python, Go, and Node.js. And now all of them run natively on COS. It's not a cross compile. You can develop directly on COS using these languages, and they get the benefits of the platform. Finally, these open enterprise languages have a no charge license, just like Java. And if you need a production level support, there's an optional pay SNS option. So on next slide, I'll talk about Go here. Specifically, here are some popular use cases that we've been working with sponsor users on and what they have been doing with Go on COS, like what I call the in-place application modernization, right? They're writing APIs, they're writing wrappers or plugins. Clients can use Go to develop RESTful APIs to communicate with existing services, plug in code to hook into other subsystems or wrappers to other API services, and extend the business logic. Porting popular Go applications, that's another key use case for Go. There are, I mentioned that there are plenty of popular useful Go applications that client can use on COS just by porting them over. And they run securely with high performance on C systems. And these applications, they already run on other platforms and they can bring them over here. For example, as part of the IBM's hybrid cloud strategy, IBM has issued a statement of direction to enable native COS containers and the underlying infrastructure using Kubernetes and open container initiatives. All those are Go packages being ported right now. This will help our clients accelerate their transformation to greater portability and agility in a hybrid cloud environment. The other use case here, interoperability with middleware and other languages. Related to modernization in place, right? Clients can write Go applications to communicate and integrate with existing middleware using COS Connect and languages like via Seagull provided out of the box. In case you don't know what Seagull is, it's a package that's part of Go, programming language that allows Go programs to call into C code, and from there you can do a lot more. The other benefits I won't spend too much time on this. Simplicity, agility, and performance. You can read a lot about the Go language itself and the large ecosystem, allowing you access to millions of developers and ready to go packages. Next slide, please. Again, this is a reference slide of a lot of good materials. I encourage if you to go take a look. You really can, like the middle one here is RESTful server setup. Really, simple 5 steps, and you get a RESTful server setup with Go, because you can just pull down ready to go stuff, and you can do that in less than a day. And connection to vSAN databases using Record IO module, and gRPC is a nice alternative to using RESTful APIs. So if you haven't have any exposure, I would encourage you to look at these videos and learn more about them. I think I will pass to Roland now for Python.
Thank you, James. So I'm going to carry on with Python. Python is almost like you can do it for anything. It's almost like a Swiss Army knife of programming languages. It is very, it's very well suited for business transformation, but it's probably the primary language for data science applications, and also, for management, like with Ansible, which basically you can automate your automate and streamline your operations for hybrid IT architecture. So that's really the one thing about these languages is that we're not just making it for our customers. We're actually also a big consumer of these languages ourselves as well within IBM. For example, with data science, we have the Open Data Analytics for ZOS. They probably have renamed to the Python AI Toolkit now. They have a new version coming out, and this is really a Python solution for integrating, for data scientists to basically get, to get data insights, right? And also with ZOAU or Z Open Automation Utilities, you can also use Python, with different, that interacts with different utilities like datasets, JCL, so you can actually have access to traditional side of ZOS as well. So let's move on to the next chart. So I want to talk a little bit about use case. We have a big, a production usage from a big, large European bank, and they're basically using it to, to build automation process and also basically looking at the in the analytics side, basically they're aggregating data, generating reports, and they're using Python to generate also dashboards and stuff like that. So it is a very exciting application that we know of that's actually being deployed, into production by a big bank in Europe. So let's move to the next chart. And here's some references as well for Python. We made some videos, and we can, to help people, and we'll continue to make them because we think customers react better or prefer video over reading a manual. So let's move to the next chart. So here are some use cases. Python can be used for obviously modernization, because you can do. Oh, sorry, this is Node.js. We talked about Python. Node.js is really a server-side, JavaScript platform where the programming language is JavaScript, but the runtime actually runs on the server instead of within the web browser. So it is really good for I/O applications, and and it's you can extend the capabilities of applications with digital transformation. Like, for example, you can write a new web front end to your applications and use APIs to connect between them. It's also very good for API orchestration because, as you know, that when we look at textbooks, API corresponds very nicely. You have a big, a very nice diagram from API mapping and all that stuff. But in the real world, right, the mapping can become pretty messy, right? So, if an API call that needs to be serviced by the systemz platform, then it'll be better for the systemz to basically have an orchestration layer to be able to coordinate all these API calls, right? And API calls are not just talking about sequence. If we talk about business logic needs to be applied there, Node.js would be the best choice here. And obviously, we have a lot of packages. We have 1.8 million NPM packages that you can actually use on the platform as well. And it's also good because you're dealing with data. It's also good to work on co-location with critical data and applications on ZOS as well. Node.js encourages a very small kind of like functional, very modular type of design. So basically, it is not inherently. It is you can actually apply agile methodology to developing these applications as well. So let's move on to the next chart. So when we make the Node.js available on ZOS, we also made some packages available or NPMs available so that you can make use of the assets that you have on ZOS. Like those things are. This is by no means the end or complete list because we still keep working on them. We have ZOS Connect access. You can actually work with ZOS assets that's exposed through the ZOS Connect application, ZOS Connect, and also Kix TS version 5.5. They actually support Node.js as a native development language. You can create packages, you can create modules, and stuff like that with Kix. It basically treats it like Java, which you can have a Node application running in the Kix region as well. So we'll have access to DB2, vSAM, and RACF, and crypto, and Rex as well. So all these things are things that we put together to help you, work on better, make your life easier working on a ZOS platform. Let's move to the next chart. So here are, again, some of the videos that we have put together, and to encourage you to go through those assets. They actually, we spent a lot of time working on them, right? So hopefully it'll be useful to you. So I just wanted to, try to summarize what we have just said, because we have a lot of information here that we have put out today, right? And And first of all, before we do that, we look at the some of the use cases for Node.js. There's an ISV called Phoenix Software. They actually use Node.js to automate the delivery of their licensing systems. And there's a big bank in Canada that use Node.js to aggregate data on ZOS so that they can develop a dashboard instead of like generating paper reports. And obviously, I talked about this big European bank of talking about data manipulation and generating reports with Python. And there is a bank in America that use Python to combine ISV data from RESTful API, with IBM Z data to generate new insights as well. So if you look at Python, it's more on the insight generation side, report generation side. And with Go, we have it's very popular with ISVs right now because they can actually port a lot of applications that are written in Go and bring it onto the ZOS platform to enhance the entire ecosystem of ZOS. So basically, we're looking at crypto algorithms or other things that they want to bring onto their platform. So I wanted to summarize here, to see what we're talking about here, right? If you concentrate or take a look at the middle part, right? We have basically a lot of business critical applications that are written already and they're running well, right? And these applications are traditionally written over decades, right? Using COBOL, PL1, and Java. Java is new, but not so new because Java is 25 years old on the platform already. They use Kixt and IMS, and then they use database and the VSAM and DB2 database or IMS database. This is mostly what a application look like, right? But if you wanted to add new capabilities to it, because we say first of all you have to optimize the core, so make sure that these applications are running efficiently on the platform, making use all the hardware features that we put into the hardware systems for you, and then when you want, and then you extend them, right? So it's no reason to replatform or to rewrite them, and then you can either use the language features in COBOL, ABO, and Java, right, to enhance them, or you wanted to write the extensions in another language. If you do another language, then you go to the right. You can actually use the open enterprise languages. The good way, the real advantage of that is that you have skills available, right? And your COBOL skills is not really readily available today, but the way that we enable these new languages are, we're not going to make them special on ZOS. They are the same everywhere on every platform, right? So we basically are using the open source community based on that and enable that on the platform. And then we add the performance side of the house into it. So we make it actually run more efficiently on the platform, right? So then you can actually use them, either you can, the key here now is interoperability, right? So either you can use interlanguage communication that we might, we're working on, or we can actually use APIs to communicate back and forth with those, with your core application. So that's a really good way of giving you options so that you're not bound to the original programming language that your application is written in. And if you're developing new microservices, obviously you're not going to use COBOL. You'll probably be using, the new languages. And then, again, if you wanted to need to connect with, interoperate with your existing applications, then you probably, you can actually use REST APIs for those. Let's move to the next chart. So that's all we have today, and we still have a few minutes for questions. I guess you can unmute yourself or ask questions, or you can actually type it into the chat. But before you do that, it's important that we get feedback from you to see how useful these sessions are. So I encourage you to submit your session feedback. So now we open it up for questions.
So thanks, Roland, James. Thank you for that insightful presentation. So guys, you are now able to unmute yourselves to pose any questions that you may have. Alternatively, you can use the chat box to do so. Not sure if anyone has got questions? Well, if not, then thank you very much for attending. Again, Roland, James, thank you very much for presenting. And I hope to see you guys in half an hour time for our next session on SDSF Hidden Treasures. Thank you all.
Thank you,
Thank you.
everyone. Yep. Bye-bye.